I get it. Comets are cool, whatever. But when the Department of Defense starts logging telescope time to monitor spectral anomalies, that has cover story written all over it. No frickin' way am I sitting this one out. This space rock is glowing, spinning, leaking metal vapors, and suddenly the data goes private? Yeah, sure, nothing to see here, folks. I've been digging, researching, tracking this so-called comet, day and night, and you won't believe what I uncovered. I've been watching a patch of sky the size of a thumbnail, just above Mars's orbital path, where a point of light keeps shifting colors. They're calling it 3I Atlas, the third confirmed visitor from outside our solar system. Green one week, blue the next, and now a copper hue that wasn't there before. NASA says it's just volatile ice and solar radiation. Maybe it is, but when an object changes color 3 times in as many months, and the Pentagon starts tracking it with the same radar arrays used for missile defense, that's when the questions begin to pile up. Tonight, the observatories in Hawaii and Chile are watching it simultaneously. Spectrometers show spikes, cyanide bands, ionized carbon, then sudden drop-offs. No one's sure if it's reflecting sunlight or releasing its own charge. I'm not claiming alien tech or divine omen. I'm saying the data don't line up. And somewhere between NASA's public reports and the Defense Department's silence, a story is forming. A story about why this interstellar visitor seems to react to our sun like it's being called home. It's early November, and the air over Los Angeles feels electrically charged. Not metaphorically, but literally. Solar monitors show the X-ray flux spiking again. 2 M-class flares just erupted from the Earth-facing side of the sun. NOAA's space weather dashboard is lighting up with alerts, and every radio operator I know is hearing static where there shouldn't be any. The same week those flares hit, telescopes in Mauna Loa, Cerro Tololo, and even the Mars Reconnaissance Orbiter began logging strange readings from that faint, fast-moving object we now call 3I Atlas. At first it looked routine, a visitor from outside the solar system coasting along a hyperbolic track. But the spectral data started changing fast. Cyanide emission bands fading, carbon lines brightening. Overall hue drifting from emerald to cobalt to a burnt orange tone Live Science says hasn't been seen in any known comet this close to the sun. I'm sitting in my apartment watching the live feed from the Las Cumbres network, and the colors don't just shift over days. Sometimes they flicker in minutes, like the object is breathing. NASA's official update describes it as volatile outgassing intensified by solar radiation pressure. But that statement went out the same hour the Department of Defense confirmed to Defense Scoop that multiple U.S. sensors are tracking the body's spectral behavior. That's unusual. Interstellar debris doesn't usually earn a military line item. Outside, the full supermoon is rising, the biggest of the year, pulling tides higher than normal, while the torrid meteor stream is peppering the upper atmosphere. Fireballs are reported over Europe, Siberia, the Pacific Rim. Seismographs twitch from Kamchatka to Afghanistan. The Earth itself feels tuned to the same frequency as the sky. It's the convergence that bothers me. Solar flares, geomagnetic surges, seismic echoes, and now a comet that refuses to stay the same color. Every telescope tracking it has to adjust calibration mid-run because the reflectivity keeps changing. That's not rumor, it's in the data logs. So here's the frame I'm working with tonight. The sun is flaring harder than it has in months. Earth's magnetosphere is trembling. And somewhere beyond Mars, an interstellar object is pulsing through the same field of charged particles, as if responding to every breath our star takes. I remember when Oumuamua made headlines back in 2017. A needle of rock that swung through our solar system so fast astronomers barely had time to point a telescope. Then came 2I Borisov 2 years later, a classic comet but with chemistry that didn't match anything local. By now we should be used to cosmic visitors, but 3I Atlas isn't following their script. The Atlas Survey, the asteroid terrestrial impact last alert system in Hawaii, first picked it up earlier this year. Just a faint streak moving faster than any typical long-period comet. Within weeks, orbital models confirmed it wasn't bound to the sun. Its speed and trajectory placed it firmly in interstellar territory. That alone made it the third confirmed interstellar object in recorded history. But discovery wasn't the surprise. Behavior was. Live Science reports that the object's spectral signature has changed color not once, but 3 times. Initial observations showed a green glow dominated by diatomic carbon and cyanide, the same gases that make ordinary comets look ghostly in the night sky. Then it shifted toward blue, implying fresh ice or new volatiles venting as solar radiation stripped layers away. And recently, the emission lines turned reddish-orange, a hue some astronomers link to metallic dust or sodium excitation. None of this breaks physics, but the speed of transition does. Normally, cometary outgassing evolves over weeks as the nucleus warms. Atlas is doing it in hours. Spectra from Chile's SOAR telescope show sharp peaks in CN and C2 dropping off between frames, as if jets on the surface are turning on and off in real time. NASA's Small Bodies database lists the object's rotation as uncertain, which means its spin rate can't yet explain the light curve changes. There's also the question of albedo. Early brightness estimates have been revised downward twice. Each recalibration suggests that the comet is darker, or absorbing more radiation than expected. The Mars Reconnaissance Orbiter even caught faint optical scattering near Mars's orbital distance, prompting NASA to label the event an anomalous reflection, later softened to photometric irregularity. So here we are, a confirmed interstellar object whose composition changes under observation, whose reflectivity drops despite increasing solar exposure, and whose tail behaves like a variable antenna instead of a passive plume. Astronomers can model the physics. What they can't model is the timing. Every time the sun flares, Atlas seems to respond, and that's the part that's making even the quiet scientists start to whisper. I started noticing the language change in the press releases. NASA's updates on 3i Atlas went from open commentary to phrasing that sounds like it was run through a filter. The words ongoing review and limited availability of spectral data began replacing what used to be real-time telemetry graphs. It's starting to look more like censorship. Someone else is looking at the numbers first. A report published by Defense Scoop confirmed what a few astronomers already suspected, that U.S. Space Command and the Defense Intelligence Agency have joined the monitoring effort. They're calling it a dual-track observation program, the same designation used when a scientific target might hold national security value. Nobody's saying why a dust-shedding rock from another star would merit radar allocation normally reserved for orbital debris and missiles, but those systems are now pointed squarely at Atlas. When I reached out to one of the researchers in Colorado who works with those sensors, she didn't deny the involvement. She just said, let's call it a cooperative data environment. That's military shorthand for don't ask more. Ground-based arrays at Goldstone and Arecibo's successor facility have been pulsing narrowband radar toward Atlas for weeks, measuring ion density in its tail. The echoes are weak but structured, repeating waveforms that look less like noise and more like interference patterns. Engineers I spoke with describe it as polarized scattering, something that usually happens when a magnetic field meets charged dust. That might fit perfectly within plasma physics, or it might suggest the comet is interacting with solar wind in a way we haven't charted before. Meanwhile, the DoD's spectral awareness team quietly added Atlas to its deep space catalog. That list isn't public. It's usually reserved for objects that could disrupt communications or navigation bands. If you map the geometry, Atlas is drifting through the same heliospheric current sheet that's producing intense solar wind compression, the same zone feeding M-class flares and radio blackouts. It could be coincidence. It could be coupling. All I know is that this interstellar fragment has gone from a curiosity on astronomers' dashboards to an active coordinate in a military command center. And once an object crosses that line, from telescope to classified screen, it usually means something important is happening, even if no one's ready to explain it yet. It started as a short update on NASA's Mars Reconnaissance Orbiter feed, a technical bulletin timestamped 3:14 UTC. Unexpected photometric response recorded near longitudinal coordinate 287.4 degrees. A few hours later, the same notice appeared on the agency's public mirror under slightly different wording. Unusual reflection pattern observed in the heliocentric frame. Nothing technically false, just more careful. The adjustment reads like the kind of language change that happens when a lab report passes through review. Those coordinates place the event in the same orbital corridor where 3i Atlas was crossing that week. The high-resolution sequence shows a faint plume extending tens of thousands of kilometers, illuminated by solar wind particles. It looks like a tail, but the alignment is wrong, angled almost perpendicular to the sun. That geometry doesn't fit standard models unless charged plasma is being redirected by something active within or around the object. NASA hasn't labeled it an anomaly, but independent researchers have. One planetary physicist told Crom.com the signal behaved more like a mirror pulse than a thermal reflection. In later editions, that quote was paraphrased simply as reflection detected, a phrasing still visible on the current page, polished but not contradictory. The timing is notable. Within 24 hours of that reading, the Defense Department announced an extended spectral coordination program, formally integrating Atlas into its deep space monitoring schedule. Cross-checking deep space network logs shows encrypted downlinks during that same window, unusual for what are normally open science transmissions. I'm not claiming hidden technology. I'm pointing to a measurable inconsistency, a reflection pattern that bends against solar geometry while the data pipeline itself becomes restricted. When plasma tails deflect in the wrong direction, it suggests the local magnetic field is being overwhelmed. That's physics, not theory. Meanwhile, every solar observatory from SDO to SOHO is recording successive M-class flares along that same longitudinal line. Geomagnetic indices rise, radio bands stutter, seismic monitors twitch. And through all of it, 3i Atlas keeps shining, a steady copper glow deepening nightly, as if its surface chemistry is evolving under constant solar stress. Maybe it's nothing more than volatile ice meeting heat. Maybe it's coincidence. But sitting here watching the feeds buffer and the language grow quieter, it feels like we've reached that line where science meets silence, and neither side wants to blink first. In the days after NASA's language shift, a kind of hush settles over the astronomy community. Not a conspiracy, more like a collective pause. Observatories that once posted nightly photometry are now uploading only weekly summaries. Researchers cite data verification delays. Journalists covering the comet are being asked to submit their questions in writing. That's how information slows down, not by being deleted, but by being delayed. And while the paperwork moves, the sky keeps going. The latest images from Mauna Kea show 3I Atlas crossing the solar plane at an angle that keeps its tail half-lit, its brightness fluctuating in pulse-like waves. It's visible, faintly, in stacked exposures near Mars's orbital radius. Astronomers note irregular polarization in the reflected light, consistent with dust grains being charged by solar plasma. That part fits the physics. What doesn't fit is the timing. The spikes correspond almost exactly to geomagnetic surges recorded here on Earth. Not cause and effect, but correlation strong enough to raise eyebrows. Even NASA's Space Weather Prediction Center seems cautious. Briefings use the word synchronous activity, which is technically neutral but feels loaded. Every time the sun flares, Atlas flares brighter. It could be coincidence, but coincidence shouldn't form a pattern. Meanwhile, social media fills the gaps. Amateur astronomers in Arizona and Spain post side-by-side images showing visible color drift over 3 nights. Spectrographs confirm that copper-red hue reported by Live Science. Sodium emission lines are strengthening. Some describe it as rusting in real time, though scientists prefer the phrase volatile depletion. It's the same process, different framing. The Pentagon, for its part, stays quiet. A single spokesperson from the U.S. Space Command told Defense Scoop that the object poses no kinetic risk to Earth and is being monitored for atmospheric research relevance. That's as close as we've come to an official acknowledgement that defense infrastructure is involved. From my desk, watching these updates trickle through different channels, it feels like the system is running 2 parallel narratives. One scientific, one strategic. Both technically true, neither fully complete. The comet remains in plain sight, yet the story around it keeps slipping out of focus. If you chart the public record day by day, you can almost see the gap widening between what's known and what's said. I keep the live sky feed running on a second monitor, the way some people keep news on in the background. The image is almost static, a copper ember moving through deep space, dimming slowly against the glare of the sun. That's 3I Atlas now. No breaking headlines, no new bulletins, just quiet observation. Maybe that's the way it should be. We build telescopes and name them after gods, but most of what they show us are reflections. Light scattered across dust, bent by plasma, filtered through algorithms. Every photon we record is already old by the time it reaches us. And still, we treat it like a secret being whispered now. What unsettles me isn't what Atlas is. It's how we react when the familiar stops behaving the way it's supposed to. The science holds, the numbers are real, but the silence between the reports grows louder every day. It's the same silence that follows a solar flare, the pause before a seismograph needle moves, or the breath we take when the world seems to hold still for no reason. Right now, Atlas is passing outward, skimming through the heliosphere, an interstellar drifter coated in ice and dust, caught in the solar wind's glare. If projections hold, it will continue beyond Mars's orbit in the weeks ahead, fading into the background field of cosmic debris. But before it disappears, it's leaving fingerprints. In the data, in the coordination logs, in the way scientists and soldiers are suddenly speaking the same guarded language. Maybe the real story isn't about the comet at all. Maybe it's about how every time the universe sends us something unfamiliar, our first instinct is to measure it, classify it, or control who gets to look. We forget that sometimes, the most unsettling discoveries aren't the ones that rewrite physics. They're the ones that remind us how little of it we actually see. I don't know what 3I Atlas is teaching us yet, but as the light from its tail fades into solar static, I can't shake the feeling that the lesson isn't in the object. It's in the way we're watching it.